Hello students, welcome to the class. So we have discussed around 20 questions. So here we have the next set of questions. So the 21st question is hemoglobin contains 0.334% of iron by weight. The molecular weight of hemoglobin is approximately 67,200. The number of iron atoms, atomic weight of iron is given 56, present in one molecule of hemoglobin is. See, hemoglobin is the red pigment for a blood. Hemoglobin, as the name suggests, it contains iron. So what they have said, it there is in hemoglobin 0.334% of iron by weight, and they have given atomic mass of iron is 56. Okay, fine. So I 0.334% iron by weight, and molecular weight of hemoglobin is being given approximately. Molecular mass of hemoglobin approximately is 67,200. Yes. Number of iron atoms. They have asked how many number of iron atoms are present in one molecule of hemoglobin. So, quantity of iron in one molecule. In one molecule. So, what we do? Approximately, what is the molecular mass of hemoglobin? 67,200 into how much percent of iron is present? It is 0.334 percentage divided by 100. So what we get? The answer comes out to zero zeros get cancelled. 672 into 0.334. The answer comes out around, solve it, 224.45. Unit is AMU, atomic mass unit. Atomic mass unit. So which is the correct option? The correct option. So here it is 224.45. So that is divided by 56. What you get? You get it around 4. Okay. So answer you will get around 4. Next question. The number of moles of oxygen in 1 liter of air containing 21% oxygen by volume under standard conditions of a temperature and pressure. So here what they have said, the number of moles of oxygen. You are supposed to find number of moles of oxygen in 1 liter of air. So volume of oxygen in 1 liter, how much they have said? In 1 liter of air. So they have said 21%. 21% comes out to 21 by 100. 1 liter, therefore 1000. So here I get 210 ml. Correct? 210 ml. Therefore, number of moles. Number of moles of what? Number of moles of oxygen. This is volume what I have got. I have to find number of moles of oxygen. So 210 ml. If it was in liters, I would have taken 22.4, but it is in milliliters. Therefore, 22.4 into 1000 comes out to 22,400. What would be the answer? Solve it out. 21 divided by 2000, 240. The answer comes around 0.0093 moles. So the number of moles is 0.0093. So what is the correct option? The correct option is option A. Yes, very simple question. Next question, the total number of valence electrons in 4.2 grams of nitride ion. Total number of valence electrons in 4.2 grams of N3 minus ion. Yes. See, each nitrogen atom has how many valence electrons? What do you mean by valence electrons? The electrons present in the outermost shell. Yes. So nitrogen atomic number is 7. It comes out to 1s2, 2s2, 2p3. or you can write it as 2, 5. So outermost shell has got 5 valence electrons. Each nitrogen atom has 5 valence electrons. Therefore, total number of valence electrons in N3 minus. So 5 into how many atoms are there? 3. We say 15, but here there is minus 1. Minus 1 means what? Gain of 1 electron. So minus 1 stands for gain of 1 electron. So 15 plus 1 comes out to 16. So nitride, there are 16 valence electrons. What is the molecular mass of nitride ion? Molecular mass of N3 minus ion. This is not the answer, students. Yes, they have said in 4.2 grams of nitrate. This is one molecule, one ion. Yes, molecular mass of nitride ion. Nitrogen is 14 into 3. So 14 threes are 42. Yes, therefore, total number of valence electrons in 4.2 grams of nitride ion. What will be the answer? It will be 4.2 grams divided by molar mass is 42 into how many electrons per molecule? It is 16 into Avogadro number. Correct? Avogadro number of particles, molecules will be there. So solve it out. What the answer comes out to? The answer comes out 42.1. So 16 into 0.1 is 1.6 into Avogadro number of particles. Avogadro number of particles. So let us see, we have that answer or no. So the correct answer is 1.6 into Avogadro number of molecules. 1.6 into Avogadro number of molecules. Correct? Okay. Moving to the next question. The number of gram molecules of oxygen in 6.02 into 10 raised to 24 carbon monoxide molecules. Gram molecules is asked, students. So we know that Avogadro number Na is equal to 6.02 into 10 raised to 23 molecules. That will be equal to what? I'm repeating the same concepts. That will be equal to 1 mole, and that will be equal to atomic mass if it is an atom, or molecular mass if it is a molecule, right? Okay. How much carbon monoxide they have said? 6.02 into 10 raised to 24 carbon monoxide molecules. Can I write this like this? 6.02 into 10 raised to 23 into 10 raised to 1. Is that right? 24, I have written it like this. Carbon monoxide molecules. What is this? This is Avogadro number. So can I mention it like this? 10 into Avogadro number of carbon monoxide molecules. I hope this point is very clear to you. I've made it very simple. 1 Avogadro number of carbon monoxide molecules is 1 mole. 10 Avogadro number of molecules is 10 moles. 10 moles of what? 10 moles of CO. Correct? So they have asked what? Number of gram molecules of oxygen. So here 10 moles I have taken. 10 grams atoms of oxygen is equal to what? If this is carbon monoxide 10 moles, then 10 grams of oxygen will be equal to what? Oxygen molecule has got O2. So 10 divided by 2. 5 gram molecules of O2. Understanding? Here there are 2 atoms. Therefore 10 divided by 2. So what is the answer? The answer is 5 gram molecules. 5 gram molecules of O2. 5 gram molecules of O2 is the correct option. Right? Okay. Moving to the next question. The number of oxygen atoms in 4.4 grams of carbon dioxide. Okay, similar question. Number of oxygen atoms in 4.4 grams of carbon monoxide. Can you tell me what is the molecular mass of, these are common compounds, you should be knowing the molecular masses. Molecular mass of carbon dioxide. Carbon is 12, oxygen is 16 into 2, 32, comes out to 44 grams. Correct. So I can say 1 mole of carbon dioxide is equal to 44 grams of carbon dioxide. that is equal to Avogadro number of carbon dioxide molecules. Is that right? So this is a known concept to us. Okay. Now they have said 4.4 grams of carbon dioxide. 4.4 grams of carbon dioxide will be equal to how many molecules? 4.4 grams of carbon dioxide means, can I say for 4.4 divided by 44, it is 0.1. So can I say here it will be 0.1 mole of carbon dioxide? So 0.1 mole of carbon dioxide means how many molecules? 10 raised to 23 is the answer. 23 minus 1. See, Avogadro number is 10 raised to 23. 0.1 means 10 raised to minus into 10 raised to minus 1. So this becomes 6 into 10 raised to 23 minus 1. That is equal to 6 into 10 raised to 22 molecules. Correct? So that is equal to, carbon dioxide has got 2 oxygen atoms. They have asked number of oxygen atoms, right? So carbon dioxide, if it was carbon monoxide, I would have written 1. So carbon dioxide has got 2 oxygen molecules. So 2 into 6 into 10 raised to 22 atoms of oxygen. Or if it was molecule, it becomes 6 to the 12. So 12 into 10 raised to 22 atoms of oxygen, or 1.2 into 10 raised to 23 atoms of oxygen. Correct? 12. Shifting decimal point to the left, plus 1. 1.2 into 10 raised to 23 atoms of oxygen. I took it in scientific notation because my options are present in scientific notation. 1.2 into 10 raised to 23. Correct? Okay. Moving to the next question. An organic compound contains carbon, hydrogen, and oxygen. Its elemental analysis gave carbon 38.71% and hydrogen 9.67%. The empirical formula of the compound would be. So they have asked us to do empirical formula. Okay, now see here. We have elements. They have said we have carbon, hydrogen, and oxygen. What is the percentage of carbon given? The percentage of carbon is 38.71. Percentage of hydrogen is 9.67. Altogether, there are 3 elements. Therefore, oxygen will be 100 minus 38.71 plus 9.67. So, 100 minus 8, 13, 8, 48.38. So 100 minus 48.38 comes out to 51.62. So percentage of oxygen is 51.62. Is that right? Because there are only these 3 elements present. Okay. What are the atomic masses? Atomic masses. Atomic mass of carbon is 12, hydrogen is 1, oxygen is 16. So let us find the number of moles. Given mass upon molar mass, 38.71 by 12, 9.67 by 1, 51.62 by 16. And this comes out to 3.22. This is 9.67. And this is 16. This also comes around 3.22. Let us get it to simple ratio. Simple ratio. So divided by simplest number, 3.22 divided by 3.22, this comes out to 1. 9.67 divided by 3.22, this comes out to 3. 3.22 divided by 3.22, this comes out to 1. So carbon is to hydrogen is to oxygen. Ratio is 1:3:1. So what will be the empirical formula? The empirical formula will be CH3O. CH3O. Let us see into the options. We have that option. So it is CH3O. Option C is the right option. If they would have given the, what you say, molecular mass of the compound, then using this empirical formula mass, we would have calculated the molecular mass, the molecular formula of the compound also. Molecular formula of the compound also. But here they have asked us only empirical formula. Okay. Next question. 1 cc of N2O, nitrous oxide, at normal temperature and pressure contains. Okay. Options are being given. One is in the form of atoms, then in the form of molecules, in the form of electrons, all of the above. Okay, let us see. Fine. Okay. They have said 1 cc of N2O. Okay. Nitrous oxide. 22.4 liters is okay. Liters, 1 liter is equal to 1000 cc. So since this is in cc, I will take it in cc only. So 22,400 cc of N2O. It will contain how many molecules? Avogadro number of molecules. 6.02 into 10 raised to 23. Avogadro number of molecules, correct? This is known to us. But here they have said 1 cc. Therefore, 1 cc of nitrous oxide contains 6.02 into 10 raised to 23 divided by 22,400 number of molecules. Yes, this is present in our option. Yes, 6.02 divided by 22,400 10 raised to 23 molecules. We usually make the mistake here, students. We immediately rush to the answer. Yeah, we do not observe the remaining options also. Sometimes that becomes very important. One is in the form of molecules. There are atoms and electrons given. So let us see in the other cases also. This is in terms of molecules. Tell me in N2O, if they're asking in terms of molecules, just find how many atoms are there in the given compound. There are how many atoms? 2 atoms of nitrogen, 1 atom of oxygen. So there are 3 atoms, correct? So I can write, therefore, 1 cc of N2O contains 6.02 into 10 raised to 23 divided by 22,400 into how many atoms? 3 atoms. 6 3s are 18 into 10 raised to 23 divided by 22400 into 10 raised to 2. This is, so above becomes 10 raised to 21, or I can write it as 1.8 divided by 224 into 10 raised to 22 number of atoms. Check out the option. Let us check out the option. Yes, this option is also present. So option A is also correct. Are you all understanding? Another case, how many electrons, number of electrons in the molecule in N2O? How many electrons? Nitrogen has got how many electrons? 7. 2 atoms of nitrogen, 7 plus 7. Oxygen has how many electrons? 8 electrons. 7 plus 7 is 14. 14 plus 8 is 22. Therefore, 1 cc of N2O contains 6.02 into 10 raised to 23 divided by 22,400 into 22 number of electrons. So how much? So cancel it out. Comes out to 6.02 into 22. Answer comes out to 1.32 divided by 224 into 10 raised to 23 number of electrons. You can see here, you have the option this in terms of molecules, which is also correct. You have option this in terms of molecules, which is also correct. Atoms, which is also correct. You have this in terms of electrons, which is also correct. Are you all understanding? Yes. So there are 6.02 divided by 22,400 into 10 raised to 23 number of molecules. 1.8 divided by 224 into 10 raised to 22 atoms. 1.32 divided by 224 into 10 raised to 23 electrons. So what is the correct option? The correct option is all of the above. So in such questions, when all of the above or none of these comes to the context, please make sure that you have checked with all the options, students. Okay. Next question. Percentage of selenium in peroxidase anhydrous enzyme is 0.5% by weight. Atomic weight of this enzyme is 78.4. Then the minimum molecular weight of peroxidase anhydrous enzyme is. So peroxidase anhydrous is a type of enzyme. So peroxidase anhydrous enzyme we have. Okay. So this enzyme contains selenium, an element which is having symbol, and it contains 0.5% of selenium. Yes. What does this mean? It means that 0.5 grams of selenium is present in 100 ml, 100 grams of enzyme, correct? 100 grams of enzyme. If you consider the molecule of enzyme, in the molecule of enzyme's atomic weight is 78.4. One selenium atom will be present. There will be one selenium atom present, correct? Yes. Therefore, I can say 78.4 grams of selenium will be present in. So 100 divided by 0.5 into 78.4. So how much you get? Solve it out. 100 into 78.47 is 7,840 divided by 0.5. Half of it, 7,840. So answer comes out to 1.58568 into 10 raised to 4. So I can say minimum amount, or you can say molecular weight of enzyme is 1.568 into 10 raised to 4. Into 10 raised to 4. So let us see our option contains it or not. So option A is the right option. Option A is the right option. Okay. Next question. Which of the following fertilizers has highest nitrogen percentage? They have given all the names of the fertilizers and they have asked which has highest nitrogen content. Ammonium sulfate. Ammonium sulfate. The formula of ammonium sulfate is ammonium NH4 twice SO4. So nitrogen ammonium sulfate. So what is the atomic mass of nitrogen? It is 14. What is the atomic mass of hydrogen? It is 1. Atomic mass of sulfur, it is 32. Atomic mass of oxygen is 16, right? So here I can write nitrogen 14 into 2 because here there is 2 plus 4 in, no, I'm sorry. 14 plus 4 2 into 2 plus 32 plus 16 into 4. This comes out to ammonium sulfate. If you calculate, this is molecular mass of ammonium sulfate. Percentage of nitrogen will be 2 nitrogen atoms. Therefore, 14 twos are 28 divided by the molecular mass, what you get, into 100. You will get the percentage. Just look at how much percentage we get. So here molecular mass comes out to 132. So 28 divided by 132 into 100, only the percentage of nitrogen comes out to 21.2%. Okay, this is option A. Now option B. This is option A. Looking at option B, what is option B? Calcium cyanamide. What is calcium cyanamide? Calcium cyanamide is CaCN2. Calcium is 40 plus carbon 12 plus 28. So 30, 40, 40, 40, 80, correct? So percentage of nitrogen, 2 atoms, therefore 28 by 80 into 100. Percentage of nitrogen here comes out to 35.0%. Okay, then what is the third option? Third option is urea. What is urea? NH2CO NH2. Correct? NH2CO NH2. How many atoms of nitrogen? Here NH2CO NH2. So 14 plus hydrogen, how many are there? Hydrogen, there are 4 plus carbon 12, oxygen 16 plus 14 plus 2. So here 2. So this comes out to 60. Okay. So percentage of nitrogen, again 2 nitrogens, 28 by 60 into 100. 28 by 60 into 100. The percentage comes out to 46.66%. And last option, option D is what? Ammonium nitrate. Ammonium nitrate, NH4NO3. Nitrogen 14, plus 4 plus 14 plus 32 comes out to 80. So that is equal to, percentage of nitrogen is equal to 28 by 80 into 100. This comes out to 28 by 80 into 100, 35 again, 35%. So if you see, percentage of nitrogen in ammonium sulfate is 21.2, calcium cyanide 35. Similarly, here also it is 35. Here it is 46.66. So in which case nitrogen percentage is more? Nitrogen percentage is more in case of urea. It is more in case of urea. Okay. Next question. The number of moles of hydrogen molecules required to produce 20 moles of ammonia through Haber's process. Very, very, very interesting questions. Haber's process, students. What is this Haber's process? It is a very important method. This you have studied it in second PUC. You'll study it in second PUC, right? It is used for, this is a manufacture of ammonia. Haber's process. Manufacture of ammonia. Okay. So what is the reaction in Haber's process? N2 gas reacts with hydrogen gas to form NH3 gas, ammonia. Yes, balance the reaction. This is balanced reaction. If you look at this reaction, I can say 1 mole of nitrogen gas reacts with 3 moles of, or volume I can say, to form 2 moles of ammonia, right? So they have asked you number of moles produced of hydrogen molecules required. Here 3 moles of hydrogen molecules are required to produce 2 moles of, so 3 moles of hydrogen are required to produce 2 moles of ammonia. So here they have asked how many hydrogen molecules are required to produce 20 moles. Direct question. So 20 moles means I need how many? I need 30. 22 divided by, so 220 into 3 divided by 2. So it is 30 moles of hydrogen are required to produce 20 moles of ammonia. So how many moles of hydrogen are required? 30 moles of hydrogen are required. Correct? Moving to the next question. The density of 2 molar aqueous solution of NaOH is 1.28 grams per cc. The molality of the solution is, and they have given the molecular mass. Even if they don't give the molecular mass, nothing to worry, because we can easily find the molecular mass, correct? So what is given? They have given density. Density of what? Density of 2 molar aqueous solution. So density is 1.28 grams per cc, right? 2 molar. What is 2 molar? Strength of a solution, or you can say concentration of a solution. It is 2 molar. Molar means what? Molarity. Of which solution? NaOH. So what is the molecular mass or molar mass of NaOH? It is given already 40. How do you calculate? 23 plus 16 plus 1. Yes, it is 40. Volume of the solution, molarity. Volume of solution will be what? Since it is molar, 1 liter, or I can say it is 1000 cc or 1000 ml. Okay. How do we find the mass of solution? Very simple. Density is mass by volume. So mass is density into volume. What is density? 1.28 into what is volume? 1000 ml. Correct. So answer comes out to 1280 grams mass. Mass of solution is known. Mass of solute, they have said 2 molar, right? So that is equal to number of moles into molar mass. So number of moles, how many? 2. Molar mass is 40. So how much? 80 grams. So when I know mass of solution, and this is mass of solute, I'm sorry, I can find the mass of solvent. So mass of solvent will be solution minus solute. So it is 1280 minus 80. That will be equal to 1200 grams. Why I need to find? Because they have asked us to find molality, right? Okay. So molality M is equal to what? Number of moles of solute divided by mass of solvent in kg. Therefore, number of moles of solute. They have not given us number of moles of solute. So what I can do? I have to first find number of moles of solute. Number of moles of solute is equal to, how much is the mass of solute? 80. What is the molar mass? 40. So it is 2. So molality M is equal to 2 divided by mass of solvent in kg, 1200. It is grams. Therefore, I will multiply it by 1000. So what would be the answer? 20 divided by 12. Answer comes out to around 1.67 molar. Yes, 1.67 molar. So let us see, is the option given? 1.67 molar. Okay. So this is how we find the molality. Next question. A mixture of 2.3 grams formic acid and 4.5 grams oxalic acid is treated with concentrated sulfuric acid. The evolved gaseous mixture is passed through KOH pellets. Weight in grams of the remaining product at standard temperature and pressure. See, very beautiful question. Organic chemistry question is being put under this inorganic part. So what they say is formic acid is being treated. Formic acid. What is formic acid? HCOOH. This is treated with concentrated H2SO4. And we know that concentrated H2SO4 is dehydrating agent. It is dehydrating agent. So what it will do? It will take out water. So it will form carbon monoxide and water. Okay. At the other place, they have said oxalic acid. What is oxalic acid? H2C2O4. This is how we write oxalic acid. COOH, COH. So H2C2O4. This is also treated with concentrated sulfuric acid. When oxalic acid is treated with concentrated sulfuric acid, the products formed are CO, CO2 and H2O. What happens is, since concentrated H2SO4 is there, whatever water is formed, it gets absorbed by concentrated H2SO4. Okay. Okay. Before that, let us try to understand this. In the initial, what are the number of moles? I'll write initial, number of moles, initial rate. Okay. Let me say how much they have said of oxalic acid, 2.3. So 2.3 grams they have said, but I want moles. So what I'll do, I will divide it by the molar mass. Hydrogen 1, carbon 12, oxygen 32, 16 plus 16, and hydrogen 1. So total comes out to 46. So I will get here 1 divided by 20. This is in the initial state. So here initially no reaction, these number of moles will be 0. Number of moles in final state, what happens? This becomes 0 and here we have 1 by 20 plus 1 by 20, right? Okay. Oxalic acid, initial state, how much they have said? 4.5 grams. 4.5 divided by 2 hydrogen plus 12 to 24 oxygen, 24 plus 2 is 24 carbon, 24 plus 2 is 26, 16 into 4, total comes out to 90. And this also comes to 1 by 20. And initially here it is 0, 0 and 0, correct? Final number of moles. Finally what happens? Here there will be 0, 1 by 20. This also will be 1 by 20 and here also it will be 1 by 20. Okay. H2O gas gets absorbed by H2SO4. H2SO4 will absorb H2O gas. Since this mixture, gaseous mixture is passed through KOH, KOH will absorb carbon dioxide. So I can say H2O is gone, CO2, so H2O is gone, it is gone. Okay. And CO2 is absorbed by KOH. So CO2 is also gone. CO2 is also gone. What remains? Yes, what remains? Carbon monoxide remains. So carbon monoxide remains. I need to find number of moles. So number of moles of CO left. How many moles of CO will be left? Left means what? Unabsorbed. They will be left unabsorbed because they cannot be absorbed by KOH nor by concentrated H2SO4. So here it is 120, 1 by 20, and here it is 1 by 20. So 1 by 20 plus 1 by 20 comes out to 1 by 10. Yes. So I need to find mass because they have asked it in grams. Therefore, I can say mass of CO is nothing but number of moles into molar mass. So how many moles? 1 by 10 into what is the molar mass of carbon monoxide? Carbon 12, oxygen 16, 28. So it will be how much? 2.8 grams. So the correct option is 2.8 grams. I hope it is clear. Yeah, very simple they have asked. So correct option is what? 2.8 grams. Is that understood? Okay, moving to the next question. What is the mass of precipitate formed when 50 ml of 16.9% solution of AgNO3 is mixed with 50 ml of 5.8% NaCl solution? And they have given the mass of silver, atomic mass of silver, nitrogen, oxygen, sodium and chlorine. Okay. So let us see how we can solve it. What they have said, 16.9% solution. See, 16.9% solution of AgNO3 means what? It means 16.9 grams of AgNO3 is dissolved in 16.9 grams of AgNO3 is dissolved in what? 100 ml of solution, correct? But they have said what in the question? 50 ml. So if I wanted for 50 ml of solution, how much grams of AgNO3 will be there? So how much grams of AgNO3? 100, 16.9 into 50, right? You will get 8.45 grams of AgNO3 in 50 ml. Correct? Similarly, they have said 5.8% of NaCl. What does this mean? 5.8 grams of NaCl is dissolved in 100 ml of solution, correct? 100 ml of solution. But I want it for how much? How much they have said? 50 ml. Half of it. So half of 5.8 is what? 2.9 grams of NaCl. Yes, is dissolved in 50 ml. Okay, let us see the reaction now. AgNO3 plus NaCl gives a precipitate. This is a reaction, typical reaction for chloride formation, for chloride conformation plus NaNO3. You will get a white precipitate of silver chloride. Okay. Initial number of moles. How much it is? 8.45 divided by molar mass. Calculate. 107, 14, 16 into 3. It comes out to 170. NaCl. Solve it out. What you will get? 0.049. NaCl. How much it is? 2.9 divided by 58.5. Correct? This comes out to also 0.049. And here it is 0, 0. What about the number of moles final? Number of moles in final condition? This will be 0. This will be 0. This will be 0.049, 0.049. Yes or no? Okay. Therefore, this is in case of moles. What we need to calculate? We need to calculate mass of AgCl precipitate. So mass of AgCl precipitate. Number of moles into molar mass. Number of moles is 0.049. Yes or no? Here it is. Into what is molar mass of AgCl? 107 plus 58.5. It comes out around 143.5. Solve it. You will get the answer approximately 7 grams. So let us see. Do we have that option? It is option B. 7 grams. Clear with this? 7 grams, option B. Next question. 20.0 grams of magnesium carbonate sample decomposes on heating to give carbon dioxide, and 0.0 grams of magnesium oxide. What will be the percentage of purity of magnesium carbonate in the sample? Atomic mass of magnesium carbonate is 24. Okay. So let us see what they have said. 20.0 grams of magnesium carbonate. This is a thermal decomposition reaction. What it is? Thermal decomposition reaction. Okay. Magnesium carbonate, solid magnesium carbonate, thermal decomposition in presence of heat decomposes to give magnesium oxide solid, and there is evolution of carbon dioxide gas. That's why we call it as decomposition. What is the atomic molecular mass of magnesium carbonate? This is 24 plus 12 plus 16, 3s are 48. Total molecular mass comes out to 84 grams. 84 grams of magnesium carbonate gives 24 plus 12. 40 grams of magnesium oxide, correct? 40 grams of magnesium oxide. So I can say 84 grams of magnesium carbonate gives 40 grams of magnesium oxide. What is the question asked? 20 grams of magnesium carbonate. 20 grams of magnesium carbonate will give how much? So 40 into 20 divided by 84, correct? So the answer comes out to 4 to the 8. 800 by 84. 9.52 grams of magnesium oxide. Here the question doesn't stop. What they have said is 8%, 8 grams of magnesium oxide they have said. Actual yield is what? Actual yield is 8 grams of magnesium oxide. So how do you calculate percentage of purity? So percentage of purity is actual 8 divided by how much we have got? 9.52 into percentage 100. What you get? 84%. So percentage of purity is 84%. So let us see, we have it in the option. So what is the correct option? The correct option is option C, 84%. Right. Next question. When 22.4 liters of hydrogen gas is mixed with 11.2 liters of chlorine gas, each at STP, the moles of HCl gas formed is equal to. Okay. So here the question is 22.4 liters. Let us first keep this in mind. 1 mole is equal to 22.4 liters, and that is equal to at STP, and that will be equal to atomic mass if it is an atom, or molecular mass if it is a molecule. Okay. They have said 22.4 liters of hydrogen. So let us find first number of moles of hydrogen. Given volume upon molar volume, 22.4 divided by 22.4. Given volume is for 22.4 and molar volume is 22. So it comes 1 mole. Okay. Number of moles of oxygen, how much is given? 11.2 divided by 22.4. So this is 11 divided by 22 is almost 10 divided by 1 divided by 2, 0.5 moles. Okay. What is the reaction? Okay, it is not oxygen, it is chlorine. Fine. So hydrogen gas combines with a chlorine gas to form hydrogen chloride gas, correct? 22.4. So initial number of moles, how much is for hydrogen? It is 1. For chlorine, it is 0.5. Then it is 0. So what does chlorine act as? See, one volume of hydrogen reacts with 1 volume of chlorine to form 1 volume of HCl, according to Gay-Lussac's law. But here it is 0.5. Therefore, I can say chlorine is limiting reagent, correct? It is limiting reagent. So how much it should be? 1 mole, but here it is 0.5. So final, how do I find? It is 1 minus 0.5 comes out to 0.5. 0.5 minus 0.5 comes out to 0.5. And here is 2 HCl. So 2 into 0.5. How much? It is 1 mole. Is that right? Yes. So chlorine is the limiting reagent. Therefore, I can say 1 mole of HCl gas is formed. 1 mole of HCl gas is formed. Correct option is 1 mole of HCl gas is formed. Right? Next question. 1 gram of magnesium is burnt with 0.56 grams of O2 in a closed vessel. Which reactant is left in excess and how much? This is also a question of limiting reagent. So what they have said, 1 gram of magnesium is burnt with 0.56 grams of oxygen. So let us find number of moles of magnesium. 1, they have said 1 gram divided by magnesium is 24. 1 divided by 24 comes out to 0.0416 moles. Next, number of moles of oxygen. How much they have said? How much grams? 0.56 grams divided by oxygen is 32. 0.56 divided by 32, so it comes out to 0.0175. So here only we get to know which is the limiting reagent. It is oxygen. So what is the balanced equation? Magnesium plus oxygen gives magnesium oxide. So 2 So it is 2. Okay. So I can say 2 volumes of magnesium reacts with 1 volume of oxygen to give 2 volumes of magnesium oxide. So initial, what is the initial value? 0.0416. Here it is 0.01750. Final number of moles. So what I'll do is 0.0416 minus, there are 2, the coefficient is 2. So 2 into 0.0175. This is for magnesium. So answer comes out to 0.0066. For oxygen, it will be 0 because everything gets consumed. And for magnesium oxide, it is 2 into 0.0175. How much it comes? 2 into 0.0175. I'll keep it as it is. Okay. Therefore, what I can say is oxygen is limiting reagent. Yes. So what is the mass of Mg left in excess? This is also asked, right? That is 0.0066 into, what is the molecular atomic mass of magnesium? 24. It is 0.16 grams. So what is the correct option? Correct option is oxygen, 0.16 grams, right? Next question. 6.02 into 10 raised to 20 molecules of urea are present in 100 ml of its solution. The concentration of the solution is. If you look at the options are given in capital M. That is nothing but molarity. So they have asked in molarity. Okay. 6.02 into 10 raised to 20 molecules of urea are present. So molecules, they have said we need to find moles of urea because concentration is in molarity. So moles of urea, given number of particles 6.02 into 10 raised to 20 divided by Avogadro number 6.02 into 10 raised to 23. So cancels out, 10 raised to minus 3 moles, or I can write 0.001. Correct? Okay. Concentration of solution. Number of moles of solute 0.001 divided by volume of solution in liters. 100 ml they have said, so multiply it by 1000. It's cancelled. So this is 10, this is 10 raised to minus 3. This comes out to 0.01 molarity. 0.01 molarity. So what is the correct option? It is option D. Option D is the correct option. 0.01 molarity. Correct? Okay. Next question. In an experiment, it showed that 10 ml of 0.05 molar solution of chloride required 10 ml of 0.1 molar solution of AgNO3. Which of the following will be the formula of the chloride? X stands for the symbol of an element other than chlorine. So they have not said what is the compound which is reacting. They said some chloride is reacting with AgNO3. So solution of chloride, if you see, solution of chloride, we don't know what type of chloride it is. Solution of chloride, what they have said, 0.05, 0.05 molar into how much? 10 ml. So it is 0.5, correct? Similarly, solution of AgNO3, if you see, it is how much they have given? 0.1 into 10 ml. So it is 1. So much AgNO3, if you look at AgNO3 solution and chloride solution, it is AgNO3 solution, molecules age of AgNO3 are double than that of chloride. Yes. So I can somehow write the reaction AgNO3 are double. That means I require say 2 molecules. And here there is some chloride with the element X. So X, let us see how many. Gives us precipitate AgCl, precipitate plus some solution NO3. Okay, so AgCl precipitate. So here there are 2, double, no, it is double. So I'm writing 2. So to balance it, I'll write 2 here. So Cl also is 2. So I'll write XCl2 plus XNO3 twice. So what is the formula of the compound? It is XCl2. XCl2 is the formula of the compound. So what is the correct option? Option B. Next question. 10 grams of hydrogen and 64 grams of oxygen were filled in a steel vessel and exploded. Amount of water produced in this reaction will be. So they have said 10 grams of 10 grams of hydrogen and 64 grams of oxygen. Okay. So see, H2 plus O2 gives H2O. So I can write here half. Okay. So of hydrogen 2 grams, oxygen 32 divided by 2, 16 grams, water 18 grams. So I can write here in terms of moles, 1 mole, this is 0.5 moles and this is 1 mole, correct? So if they have said 10 grams of hydrogen, 10 grams of hydrogen, if 2 grams of hydrogen is 5 moles, 2 grams of hydrogen means how many moles? 1 mole. So 10 grams of hydrogen means how much? 10 divided by 2. 5 moles of hydrogen. Correct? Okay. 5 moles. 16 grams of oxygen means 0.5 mole. They have asked 64 grams of oxygen. 16 fours are 64. Therefore, how many? 64 divided by 2, it is 2 moles of oxygen. So in this reaction, if you look carefully, oxygen becomes the limiting reagent. So oxygen is the limiting reagent, right? Since 0.5 moles of oxygen, 0.5 moles of oxygen is giving how many moles of water? 1 mole of water. Here how many moles of oxygen are there? 2 moles of oxygen will give how many moles? 0.5 is giving 1 mole. 2 moles will give 4 moles of water. It will produce how many? It will produce 4 moles of water. So option B is the right option. Is that clear? Understood? So write the reaction. Look, balance it. Looking at the balanced reaction in the form of moles or in the form of volume, you will get to know whether the question is on limiting reagent. If not limiting reagent, you can understand it directly. But if the question is on limiting reagent, you have to identify the limiting reagent. And here in this case, oxygen is our limiting reagent. So if 0.5 moles of oxygen is giving 1 mole of water, then 2 moles of oxygen will give how many? It will give 4 moles of water. Correct? Okay. Moving to the next question. 23.5 grams of sodium carbonate is dissolved in enough water to make 250 ml of the solution. If sodium carbonate dissociates completely, molar concentration of the sodium ions and carbonate ions are respectively. Beautifully framed question. 23 grams of sodium carbonate. What is sodium carbonate? Na2CO3. Let us calculate the molar mass. Molar mass of Na2CO3. So it will be 23 into 2 plus 12 plus 16 into 3. So 46 plus 12, 48. So how much we get? 106. 106 grams is the molar mass. So molarity of solution. Number of moles upon volume of solution in liters, correct? So number of moles is not given, but they have said 25.3 grams divided by 106, the whole divided by 250 ml divided by 1000, correct? In 1000 we want. So here it is 25.3 divided by 106 into 1000 divided by 250. Solve it out, we'll get the answer 0.955 molarity. This is molarity. They are saying Na2CO3 dissociates completely to give Na plus ions and CO3 minus 2 ions. Balance it, right, like this. So if I want to find concentration of Na plus ions, it is twice concentration of Na2CO3. So can I write it as 2 into 0.955, which comes out to 1.910 molarity. And that of CO3 minus 2, there is only one molecule, it is concentration of Na2CO3, right? That is 0.955. So for concentration of Na plus ions, it is 1.910. Concentration of carbonate ions is 0.955. So which is the correct option? It is 1.910 and 0.955 respectively. So this should come first for Na plus ions, and this comes next for carbonate ions. So we have discussed around 40 questions. In the next, we'll be taking next few more questions, because there are many questions based on many more concepts. We'll be saying on mole concept, few more questions, molarity, molality, mass percent, and mole fraction. We'll be taking few more questions on all of them. Okay, hope the answers are clear, all the concepts are clear. Thank you.